Hello, my name is Marta. Welcome to the last video of the field methods in remote sensing. Here I'm going to finalize with some advices about planning field work. More things to consider is temporal aspects. For example, does the field work needs to be simultaneous to image acquisition? For example, if it is for field moisture content, if you take the field moisture content 1 week before the image acquisition, the moisture may change dramatically in 1 week, so that data is not going to be useful. But for example, if you are measuring tree structure, 1 month or even I could say 2 is not going to make much difference unless you are working with deciduous trees that may lose their leaves, and you may have that into account. And also within temporal aspect, there are certain requirements for methods and instrumentation, especially with regards to illumination conditions. As we will see, for example, to take hemispheric photography to measure the leaf area index of the trees, you need either cloudy conditions, or you need to take the photos very early in the morning or late in the afternoon, so you don't have a direct sun exposure in the camera. To plan the field work, you need to have into account the characteristics of the variable to be measured. This means, for example, how variable this variable is. Is it constant during the day? Is it variable through the day? Does it have a strong seasonality? All these things need to be considered to plan your field work. Then you need to consider the sampling unit, the pixel size, that will, as we have mentioned before, determine the size of the plots. And then you have to consider the type of sampling you will do and the sample size. And I will extend on this in the next slides. So there are 5 different types of samplings in the field. One is the simple random. The purpose of a simple random sampling pattern is to ensure that all parts of the project area have an equal chance of being sampled with no operator bias. The second type of sampling is the stratified random. So a stratified random sample pattern maintains a necessary randomness and overcomes the chances of an even distribution of points among the different land cover categories, for example. There is another that is systematic sampling patterns that assigns a sample point to positions at equidistant intervals. For example, all grid intersections. The fourth type of sampling is a systematic and aligned pattern that uses a grid, as in the systematic method described above, but assigns the position of each point randomly within the grid cell. In this way, a degree of randomness is maintained within the constraint of a grid cell, but the grid assures that all parts of the project area will be sampled. And finally, there is a sampling type that is clustered. In the cluster sampling approach, nodal points are used as centers for clusters of sample points radiating from the center. Any number of nodes can be selected, and any number of satellite points can be tied to them. From a practical point of view, a cluster sampling approach has some important advantages to a field survey. For example, in terrain with poor access, this method allows the operator to make the most of the accessible sites. So once you have decided on your sampling type, how many samples should you take? Well, this depends on the probability confidence level given to your estimates, and also the characteristic of the study area. In general terms, the more heterogeneous the area is, the more samples you need to take to have a representative sample of the area. In remote sensing and more specifically in image classification applications, some authors have recommended to take at 10 times the number of bands in an image. This is, for example, imagine you are using Moody's data that has 7 bands. You should at least take 70 samples for each category. This author just states a single number, 50 samples per category. But there is also this equation that says that the number of samples needs to be a function of the confidence level, the expected accuracy, and the allowable error. All right, so to summarize, with sampling planning, some practical advices. It is very important to justify the choice of sample. Either you select a random or a stratified sampling, you need to justify why you have selected that. For example, sometimes it's absolutely necessary to reject a sampling point because there is not accessible, or it is in a border area, so it includes a mixture of different land cover types and it's not homogeneous. So if this is the case, just explain it clearly. As we have mentioned several times, possible position errors must be taken into account when selecting the site of the sampling areas. And this is an equation that is out of there to know the minimum site of the sampling area that you need to establish. That is a function of the pixel site and the accuracy of the location of the GPS. You need to assess the homogeneity of the plot and the resolution of the image to plan your sampling. And then you need to decide how to perform the measurements in the plot. Depending on which variable you are measuring, you should decide to do transect or triset in diagonal or slat starts, or simply randomly collecting the samples in the plot. All right, so with this, I have finalized with this little part of the course. I hope you enjoyed, and I'll see you on the class soon.